Hello and welcome to our lecture that is all about the tides or the movement of the oceans. I have a video right here for you. I'm going to put the link in Canvas and absolutely, definitely watch this video. A nice British fellow explains the tides and the earth using an orange, a string, an M&M, and a cookie, which he calls a biscuit. It's about 4 minutes long maybe, but it's definitely worth watching at least once, possibly twice. It really helps explain kind of how the tides are formed, what celestial bodies are involved, and all that good stuff. So check that out. Let's get started on our tides notes, shall we? If you will. Our notes look like this. This is where we're going today. Tides are the daily changes in sea level of ocean. You are all fairly blessed to be studying this and live so close to the ocean as you do. I can't imagine having to be a student studying this, say, in the mountain region where this isn't exactly as a noticeable phenomenon that you would see. Hopefully you have all seen the tides before. If not, maybe we'll take a trip to the ocean when we can take field trips to kind of look at this phenomenon just a little bit better. Oceans are definitely awesome places for science. But again, the tides are the daily changes in the sea level of the ocean. It is caused by the gravitational force of the moon. The moon takes about 24 hours and 50 minutes to pass over all of the oceans. That's why those 50 minutes is actually why we get the shifts of the tides. So tides like low tide time and high tide time will shift by about 50 minutes every day. If you look here, you can see, and hopefully, well, you probably haven't watched the Cookie Guy yet, but you will. He's going to explain to you how the placement of the moon and the earth and the sun really play an effect on the tides here. So we have our highest tides when the moon and the sun are pulling in the same direction, or as the moon is directly, or wherever the moon is, we're going to have high tide. And on the opposite side of the earth as well, where the moon is not or perpendicular, we're going to have low tide. So if you can see right here, this line, similar to the rubber band in his video, is what we call a tidal bulge. It's just a representation of the gravitational pull of the earth on the moon. Now the moon is not massive enough to actually pull the earth any which way direction like the sun does, but it is massive enough to have an effect on the oceans, and that's actually why we get the tides. So the moon's gravity is pulling on the ocean here, and as it pulls, so if you can imagine this, if the earth is spinning, the moon is going to shift or go around, and with it the tides as well. So when the moon is, say, right here, high tide is going to be right here and right here. Low tide is going to switch right here and right here. Here is a picture for you just in case you've never seen the effects of tides before. There's low tide. Low is where the water is pulled all the way out to the ocean. And then high tide, if you can see right here, same area. These docks are actually designed so that they float so they can accommodate for the tidal shifts. But it is much, much higher up here. So if you're looking, this area right here would be completely covered with water, it looks like on the picture. You can kind of see where the soil is a darker color or it has more water in there. That's because of the tidal changes. Our tidal range, let me move my face real quick, is the difference between the high and low tide for a specific location. So this might have a, let's see, if my estimate for measurements is not always the best, but I would say that is probably about, so let's see, that's a truck right there. Truck is probably about 7 foot tall. So maybe a 20-foot tidal range right here. That's a big estimate. I'm not sure if that's exactly right, but 20 foot sounds about right, of a tidal difference between the lowest low tide and the highest high tide. Now, here we are again, an example of that high tide and low tide. If you were to guess, which I can't ask you in person right here, but which one is high tide and which one is low tide, do you think? The high tide is this one right here with the water, very up, very present, and this one right here is actually low tide, so much so that our poor boat is sitting on the mud. Again, if I were to ask you, what do you think this is, high tide or low tide? I hope that you would say this is low tide. And again, high tide or low tide, I'd hope that you would say this is high tide. It looks to be the highest that the water is. And same space, low tide. Can you see how large of a difference that is right there between high tide and low tide? That is just crazy. It almost looks like that boat is suspended, which it's not, but suspended by those ropes. So just a crazy amount of difference between the high tide and the low tide, and that's all because of the gravitational pull of the moon on the Earth and its oceans. Now we're going to talk about this thing called spring tide and neap tides. Now spring tides, they both occur twice during the month, but a spring tide is when the sun and the moon are aligned. So if you can see, the sun, the moon, and the earth are all in a straight line. We call that a 180-degree angle. And this produces a higher high tide and lower low tides because the gravitational pull from the sun and the moon are working together to pull the oceans of the earth. In contrast, a neap tide occurs when the sun and the moon are at a right angle, and this produces a smaller high tide and low tide. So we have less of a difference between high and low tide during our neap tides because these are at a right angle, so they're pulling in opposite directions, making it not as strong. So these are really, really high tides and really, really low tides. And if you can tell, the question I might have for you would be what phase of the moon, because we've already studied astronomy, is the moon in during these stages. And during a spring tide, it's got to either be new moon or full moon, right? We talked about this. You cannot see any of the lit up portion of the moon here. You can see all the lit up portion of the moon here. Or it's going to, and our neap tides are going to be during our first quarter moon and our third quarter moon right here, where we can only see a half of the lit up side of the moon. Wonderful. So this happens during full and new moon. Please write those down. I know there's not a section of that for your notes. Copy these diagrams as well in your notes. This is something you will see for sure on a test. Monthly tide cycle. So when the sun and the moon line up in a straight line, they have the combined gravity of the sun and the moon. They have an effect on the Earth's oceans, causing them to rise by at least as much as 15 meters, which is a very large amount. These very high tides and low tides are called spring tides, and they happen every 2 weeks. So these are in your notes. You've also got to answer there that they happen during a new moon and a full moon. And the daily tidal range is at its greatest during this time, meaning that there's a large difference between high tide and low tide. You can see that here. The tidal bulge is very, very large for your high tide and very low for your low tides. And then neap tides, when the sun, moon, and earth are perpendicular to one another, we say that we call this our neap tides. The gravitational pulls kind of I say they cancel them out, but that doesn't mean that they're not pulling just as hard. They're just pulling in a perpendicular direction. So you have a force going this way and a force going this way. Instead of right here, we have the forces going in the same direction. Okay, these are called neap tides. They result in weak high tides and low tides, meaning that it's not a very high tide and it's not a very low tide. The tidal range is at its smallest during these times. And remember, please, that this happens during a third quarter and a first quarter moon. Very awesome, very exciting. And more to tell you. The friction created between the water and the ocean floor slowly rotates the Earth. It's only slowed by 10.8 minutes since the dinosaurs died. That's just a little fun fact between as far as is this tidal force that in and out of the tides having any effect on the Earth. It kind of is. It's slowing the rotation, but not by any measurable amount that you could see during your lifespan. Now we also have this thing, and it's how we classified the different tides. We have diurnal, semidiurnal, and there's another one. Let's see, a mixed semidiurnal, which we're not going to talk very much about, but a diurnal means that you have one high tide and one low tide a day. You can see this in places like the Gulf of Mexico. But we also have semidiurnal, which means that you have two high tides and two low tides a day. We can see this on the East Coast. So this is the kind of tide we have. If I asked you, what kind of tide do you see in Wilmington or any beach on North Carolina, you would say semidiurnal. We have two high tides and two low tides a day, typically about 12 hours apart. Wonderful. These images are sponsored and from NOAA, one of my favorite organizations, North American Oceanic and Atmospheric Association. Wonderful, wonderful. I have a friend named Andy who works from them. Make sure that you are checking out those graphs right there on your notes for this as well. And just a picture to kind of show you what kind of tides we have around the world, if you've ever wondered. Right here you can see the East Coast, we are semi-diurnal, and then if you look in the Gulf of Mexico, like Florida, we are diurnal, meaning one high tide and one low tide. We have two high tides and two low tides, and you're going to see that all the way up into Maine and parts of Canada, Greenland, Britain, most of Africa. You see a mixed semi-diurnal tides, which is that weird one we didn't really talk about. We can go back to the graph just to look at it. It's kind of wonky, you know. We're not really sure how many high tides we have, how many low tides we have, how they look. It's just weird. You see that in parts of South America, on the West Coast. Alaska, we have those diurnal tides again, where you just have one high and one low tide. And then maybe if you were interested, not sure, but over here in the, not so good with my Asian geography, around in here somewhere is Japan. I'm feeling like it's right around here and it's mixed semidiurnal, but I could be so wrong, so we'll move on to this part of India right here, which I know for sure is India, and that's a semidiurnal tide. The other side, in contrast, though, is mixed semidiurnal tides. And let's talk about flood tide, ebb tide, and slack water. So flood tide, that's a fancy sailor word for saying water that is coming in. Ebb tide, in contrast, is water that is going out. So a flood tide would be the water moving in as we are moving from low to high tide. Ebb tide would be water that's going out as we're moving from high tide to low tide. And slack water is the time between the flood tide and the ebb tide. All sailor or ocean terms, not necessarily something that I would ask you in science class, but good to know. We're expanding our vocabulary. And the last thing that we are doing on this set of notes is called the tidal bore, and it is the surge of water that rushes upstream at high tide. You can see it pretty clearly right here. So that's the water that is coming in during high tide from the ocean, with it anything that was in the ocean as well. Wonderful. There it is again. Isn't it beautiful? I really do love studying the ocean. It's one of my favorite places to be, and I love learning about it just a little bit more because it is so odd. Wonderful. So there is a tidal bore with a surfer who's taking advantage of the surge of water that is rushing upstream during high tide. More of it. So many more. Oh, that's because I was going in the opposite direction. All right, so just a little fun fact. The Dream Mark is a 20-kilometer, which is about 50 minutes of constant surfing on this wave. That is 50 minutes on a wave traveling at around 15 miles an hour with the power of the Atlantic tide behind you. Maybe that's a dream of mine, to try and find this and see. First step, though, is to learn how to officially stand up on my surfboard without falling down. We'll see if we get there. All right, that's it. We are not doing the tides graphing activity because I do believe it's something you definitely need to be in class with me for. So have a great day. I hope you enjoyed our journey learning about the tides. I will check in with you tomorrow. Don't forget to submit this assignment to Canvas.